There's a disk or circular plate, whatever you can call, and there's a point charge is what we have kept it here now. So the flux given by, according to the Gauss law, the flux linking this, any surface, the formula is given by Q ohm by 4 pi epsilon naught, where this is called as solid angle. Solid angle subtended by the surface. Let me not go in detail geometrical, just we'll have a formula, we'll learn how to utilize, that's all, finish over. So what do you mean by solid angle? Next question comes like, you can see here, like here, this particular point charge will subtend some angle, no? I'm going to measure that. It's a three-dimensional angle, better you can call that one. What is solid angle? It's a three-dimensional angle. This particular angle, what I'm going to measure is called a solid angle. So how to find out that one? How to find out that one? So that is given by the formula 2 pi 1 minus cos theta. What is theta? Theta is this particular thing. I think you can calculate cos theta. What is cos theta? X by root of r square plus x square. So in brief, what is solid angle? It's a three-dimensional angle. Theta is what? The plane angle. Like we say like a radians. We'll mention radian. What is solid angle? Unit for that will be steradian. Okay, let's not go in detail because we need a lot of time, and anyway we are not going to learn, and for different types of surfaces the formula will change. This is for circular disk. When the surface is a disk, surface is what? Circular surface here, then there's a formula. For a square, one more formula. Rectangle, another formula. For rhombus, again different formula. For and triangular plate, again different formula. Like that, the different types of surfaces, the solid angle formula will become different. There's a just if you look at the advance also, till now we don't have anything on solid angle, but in SURMA and most of the books they have discussed. So let's have a discussion on it. A formula based discussion. Let's have it. So how to calculate the flux linking the circular disk? For that, if you know solid angle, it'll be much easier. Q like the solid angle by 4 pi epsilon naught. Like this one. What do you mean by this? If you rearrange, actually it will come like this. Q by epsilon naught. This is actually the correct form. Now, if you imagine this point charge present in a solid sphere, what is the flux linking this? You are going to write Q by epsilon naught. Then what is the solid angle for this? Will become 4 pi. So what is the solid angle for a like a sphere? It will be like a for spherical surface. It will be 4 pi. Getting the idea? So some through comparisons we'll try to learn. Actually, we should go for a separate geometry is there. That one we're not going to focus on that particular geometry, not part of syllabus. So therefore, I'm just through formulas, I'm trying to explain the basic idea.
Sir? How to calculate the solid angle, sir?
How to?
Calculate the solid angle, sir.
How to calculate solid angle, you don't know. Just a formula is given and you have to apply it.
Okay.
It's a three-dimensional angle that is measured for this one. So what is the angle subtended by this surface means you are going to measure this one. This is called like a solid angle.
Okay. Thank you.
Okay, ma? So this is it's having wide importance when we go for the 3D objects. Solid angle, sir, what is solid angle? I'm unable to measure. That's what I'm saying that one as we go for different surfaces, no, you'll get a picture. I'm just taking circular disc and solid sphere. So this is a solid sphere now. So like this is a spherical surface. What is the solid angle of it will be 4 pi. So what is the method? Sir, what actually you mean to say? What we have to do is like, first you assume a cone. Fine. The elemental surface, say ds. This small angle you measure it, d ohm. Like that, can we assume this spherical surface made up of such cones? And add up angle and add up all the angles subtended by that cones at the point at the center. Then how much you get? You'll get equal to 4 pi. Again, assuming cone, again, it's a 3D diagram, very difficult here. Like that, not only it's a plane diagram. Don't assume that's like a 10, 15. You should assume radial direction cones. All such cones, what happen when you join, when you, all the apex of cones should be at the center of the sphere. So then what happen? All the base of the cones, they'll make a surface of a solid sphere. Angle subtended by one elemental cone, that will be d ohm. When you add up all such angles, it will become equal to 4 pi. This is actually the meaning. Now you can see this.
The DM is also spherical angular, sir.
So it's also a three-dimensional. So don't bother about that one. Got this? So no, the solid angle subtended by the disk. So definitely it should be off of it. It should be less than 4 pi. Will agree? So you draw a sphere. So what is the angle subtended by the sphere at the center is 4 pi. What is the angle subtended by this circular disk, which is a part of it, should be less than 4 pi. It is given by this particular formula. So what is the solid angle? How to calculate? 2 pi by half cone angle. What is the theta? Theta, we'll call it as half cone angle. How to calculate theta? We have directly a formula. At what distance I am. So as I move away, you can see, I'll justify my answer. As I move away, what will be the value of theta? Decreases. As x increases, theta decreases. As theta decreases, cos will increase, then solid angle will decrease. Am I right? Justified. So as you move this point charge near to it, x will decrease, theta will increase, cos theta will decrease, solid angle will increase. So now how much of flux through this particular circular plate or circular disc given by this particular formula? Substitute here. Q by 4 pi epsilon naught 2 pi 1 minus cos theta. 2 pi get cancelled, so Q by 2 pi epsilon naught 1 minus cos theta is x by. So as you vary x, yes, definitely the flux linking this circular disc is going to change.
Sir,
Ah.
can you repeat the formula you said for half solid angle, sir?
There's a formula 1 minus cos theta.
No, so you said something related to half angle, na, sir. Some you said some formula in half
Cos
angle.
theta, cos theta. Theta is like a half cone angle. Now, what is theta? Half cone angle. Are you seeing some cone?
Yes.
It is called as a half cone angle. Theta is called as a cone. No, I think you know cone.
Yes, sir. Okay, sir. Got it.
2 theta is a like a cone angle. We say half cone angle. This is called like a cone angle. No, this is half cone angle is what? Theta.
Yes, sir. Understood.
Just simple, some terminology. I'm just directly through formula. What happened? Better to learn, because we can't go to solid angle thing, that one. This is for circular thing. What about, sir, like a for rectangular plate? Definitely. So for rectangular plates, let me. I have to draw a rectangular plate. Yeah.